Hello again. Thank you for joining Building Data and AI Product Set on Data Science Conference Europe. Hope you've been to our Discord channels. Before I present our speakers for this slot, let me tell you that our community partner of the conference is also Civus, a software development and consulting company with over 900 IT experts worldwide. Their portfolio includes successful stories with global telecom operators, organizations from the banking and finance sector, technology companies, and many more. Visit Civus' booth at Expo Zone and reach their representatives at our Discord channels. If you'll have any questions for our speakers, please do post them in the chat box and we will have a short Q&A at the end. Today, Bogumil Kaminski and Przemyslaw Szufel come from Warsaw School of Economics from Poland, and they will be giving us a talk over Julia is ready for production, practical applications. Welcome both. And to explain a bit more on the topic, they said, we have spent over 20 years now deploying data science related projects in corporate environments. When we discovered the Julia programming language in 2015, it was still in its infancy, but we were attracted to it for its great number crunching capabilities. However, during the years of using it, they have learned that its current level of maturity makes it a great tool for deployment in production. In their talk, they will present practical applications of the Julia language, and using these examples, they will highlight what features of the Julia language and its package ecosystem make it an attractive environment to learn and use for your next data science project. To pass over, please start and let's enjoy this.
Okay, thank you very much for introducing us. My name is Bogumil Kaminski and I am a professor at SGH Warsaw School of Economics.
And I am Przemyslaw Szufel, and I'm also I'm an assistant professor at the Warsaw School of Economics. I'm also involved in venture capital markets and helping companies with designing data science products.
Yes, so the idea of this talk is the following. We have started using Julia in academia and developing package ecosystem for Julia, but both of us have some connection with the industry. So I am doing a lot of projects that combine academic research and its applications in business. And Przemysław is also, as he has just said, managing a VC fund where they are investing in different startups and companies, where actually also the use of advanced data analytics solutions is pretty common. So we would like to share today with you our experience over the topic, is Julia is ready for use in business, because the fact that it's ready for use in academia is currently not really disputed because it's widely used there. But the question is, can we safely start using it to do commercial projects that are intended to be used in production? And the agenda for today is consisting of 3 points. So first, I will talk a little bit what is Julia and what are its crucial features that make it ready for production currently. Then I will pass over to Przemek to discuss a concrete example of how Julia can be used, especially in the context of building applications that have geospatial data analysis. And finally, I will wrap up with an overview of other applications, a more high-level one, and a summary. So let me start with the question, why Julia? So when I am considering this issue, why would I use Julia for my next data science project? There are actually 4 factors that come into play. So first is performance, so that it's really fast. The second is expressiveness, which means that from my experience, you can not only run your code fast, but actually you can quite efficiently develop a new solution in Julia. The third thing is composability, which means that if you are using Julia, it's really easy to compose it with existing solutions, no matter how they were developed previously. And the last thing is tooling, so how the ecosystem of tools around Julia helps you to develop a robust production solution. So let me go over those 4 points quickly before I move on to Przemysław with a concrete example of application of Julia. So the performance of Julia is best compared when looking at this chart, where we can see different programming languages and their speed relative to C programming language, which you can see here in the first column. On several benchmark problems, y-axis is on logarithmic scale. So if we move from one level to another level, this is 10 times slower execution time. So as you can see, Julia is a compiled language, so it is as fast. Its speed is comparable to C, to Rust, to Go, to Fortran. So this makes it fast in the first place, but what is also important that it has built-in support for multi-threading and for distributed computing, which means that many things that in other languages require additional tools like Spark are not needed in Julia, because when you just use Julia, you get the ability to, for example, use multiple cores in your program out of the box. Similarly, Julia has a native GPU support, which means that if you write Julia program properly, you can compile it to be run on GPU instead of CPU. So those things make Julia fast. The second thing is that, of course, speed is important, but the question is it convenient? Because there are very fast languages, but that are very hard to code with. So this is the second chart that compares runtime, code runtime versus code length. So as you can see, on x-axis we have code length for similar program, and for y-axis we have runtime. So runtime comparison is similar to the last chart, where we can see that Julia is on level with Go, Fortran, C. This is the same relative speed, but what we can see that on the other hand, in terms of code length, Julia is as scarce as, for example, R or Python. So you can actually get this very good performance I have discussed on the last slide, but with code that is relatively short. So what it makes it possible to achieve both? So first of all, because Julia was designed where already R, Python, and other languages were well established, it has a modern syntax taking best parts of other languages that pass the test of time. In particular, it has inbuilt linear algebra support. So it's unlike, for example, Python, where you have to add extra libraries to do operations on arrays, matrices, and so forth. In Julia, it's built into the language. The third thing that is very important, especially when building larger projects, is that if you install packages, each package is isolated, which means that there is a very low risk that if you use several packages that they will clash somehow. So this means that you can very easily build larger projects that compose several packages without a big problem. And in particular, this is achieved by extensible type system, which means that if you have your own objects that have to have specific properties, you can define your own types in Julia that are as fast as inbuilt types. So if you define your own type of data, it's as fast as, I don't know, inbuilt floats, ints, or strings. But on the other hand, you can provide them with any behavior you would like to have. And finally, one last thing is that all code is normally written in Julia. So you do not have this situation that you have, for example, I don't know, TensorFlow for Python, but most of it anyway is written in C. Most of the packages in Julia are written in Julia. So why is it good? Well, it is good because you can very easily check out how this code works, or even if you would like to tweak it somehow, you can just edit the source files that are in Julia and everything will work as you would like it to work. So those whole things make Julia expressive. But one thing that I have hinted already that is really crucial is composability, which means that as opposed to other packages, because we have this extensible type system and multiple dispatch, we can follow the Unix philosophy in Julia. So each package does only one thing, but it does it well, and then packages just work together. And later Przemysław will show some examples of such an interop. But what it means that you don't have to hard code, for example, that I don't know, data frames package should work with plotting package. It just works because those two parts of the ecosystem are orthogonal, and Julia compiler takes care of making them interoperate. So this is, I would say, an opposite idea to how, for example, pandas works, where you have a lot of things inbuilt into pandas to make sure that play nicely together. Both approaches have their pros and cons, but this Unix philosophy, at least I like it very much because it makes it much easier to build, as I have said earlier, larger programs where each part of the program can concentrate on doing one thing well, and then if you need to change it, you don't have to think so much about how the interfaces change. And one example of it is that there is a common API for tabular data format. But actually in the Julia ecosystem, like 100 different packages already support this common API. And this means that like you have 100 packages that do very different thing, but all of them can be queried as a table, the output, what those packages produces. And this is very powerful because then if you have a querying framework, you don't have to think about from which package will I get the data. You just write a query and you know that if the source follows the common API, everything will just work. Last but not least for the composability is that the composability is not within the language, but actually you have a transparent integration in both ways with external code. So if you have legacy code in Python, in R, in C, in Fortran, MATLAB, etc., you can integrate it within Julia code, and Przemysław will soon show you an example of such an integration, that it's really seamless. For a programmer, you wouldn't even know which part is run by Python and which part of code is run by Julia. It will just work, and it is really powerful because this means that you have one environment, but if you have components using another technologies, it's completely no problem to integrate them. Finally, the tooling. So the language itself is nothing unless you have appropriate set of tools that make it easy to deploy things to production. And in Julia, again, because it was built later than other languages, from the very start, it was taken into consideration. So, for example, you have an inbuilt package manager, which already within the language has an excellent dependency resolution algorithm, which means that you can very easily detect which versions of packages work with which versions of packages, and you can even store the state of the dependencies in simple manifest files, which then specify exactly the state of the environment that the code that you are developing should work with. Or for example, you have automatic tools for pre-building binaries for most targets. So if you want to produce binaries that are part of your project, you can automatically build it with Linux, OS X, Windows, and other targets. And then when you install those packages, correct binaries will be fetched automatically from the package serving repositories. The second thing with tooling, which is maybe tiny, but I think it's very important, that essentially everything is under MIT license, which is very flexible. And for business, it's often important that you have a permissive license for the tools that you are using. Finally, I will not go into details, but Julia language in general is a language for data science, but you have all those tiny components often required for production deployment that are not core data science parts, but are often needed. So for example, it's really easy to build microservices using Julia. There are components for web development. You can compile Julia code into a standalone executable application, so you don't have to install Julia itself in order to run Julia application. And finally, Julia has very good support for development. So the major and most common is VS Code integration, but you have an excellent Jupyter Notebook integration. And in Julia, you have something that is called Pluto. Pluto is actually a next generation Jupyter Notebook. So how does Pluto differ from Jupyter Notebook? The difference is that in Pluto, Pluto is reactive. So if you change the value of the variable, the whole notebook gets recalculated. And this is very useful, especially in demo or live work. So having spoken about those four aspects of the language, let's see how they work in practice. And here I pass over to Przemysław.
Okay, thank you. So this is a demo of a project where this is a commercial project where we want to decide whether and how it makes sense to build a new shopping center. And now the big advantage of Julia in this kind. So we have what we have see here. We have a scenario when we have either 2 or 3 shopping centers, and we want to decide how they are going to attract new customers who are moving around. Now, the big advantage of Julia is that we can build this type of models in scale 1-to-1. So it is really possible to have entire city inside of Julia simulation of a digital twin of a city built into Julia, put a population of 100 or even 1 million vehicles and drive them around. Can you, the next slide, please? Okay, so we build models where we take the entire area of people living. So this is one example of application, which is Winnipeg, Canada, with 1 million residents who are driving around the city with their vehicles. And we try to, in the digital twin model of the city, we try to reflect the real population. Can you move further? So we get a model that we're modeling the people traveling between home, work, shopping centers, and other their points of interest. And by having several 100,000 of vehicles driving around the city, we can model each part of the city and understand what is happening there. In the end, we can collect statistics about what is happening where in the city, and we can also assess the things like location of a new shopping center being opened and how many customers it is going to attract. Can you move that to the next? So the main point here is, so this is a part of our synthetic population. So the main point here is that in Julia, you can actually model the real world. You can build a digital twin of the world in the scale 1:1, which is essentially not possible in other programming languages, because on one hand, you have lots of programming and lots of logic to design. And on the other hand, you have the efficiency of execution. So, so this is what Bogumil said at the beginning. I could have language that is simple to design, but then I'm not able to build a digital twin of the entire city. Okay, I think we can move forward. So this software, so part of this project here is also licensed under MIT terms. So you can have a link at this slide and look into demos and how to program this sort of models in Julia. And this is applied by us to solve real world problems. Now, other applications, we are actually having other projects in that area, and this includes COVID pandemic modeling when we have a digital model of a city, again, and people spreading the COVID pandemic, a smart optimization of retailer unit locations. So this is what has been presented, but also we are working on design and optimization of communication systems for smart vehicles. So we have smart vehicles communicating, and we want to optimize how they can communicate. Also, another possible application is to design new. So this is another area of research we do. It is to design new mechanisms for co-payment for usage of road systems. So these are all very practical applications, and I honestly cannot imagine doing it in other tool than Julia. Okay, thank you.
So Przemek has presented applications that are geospatial data related. Why it was relevant? Because those applications use really loads and loads of data and require very computing intensive operations. But there are other real cases that I have listed here that Julia worked very well in different industries. So for example, in pharmaceutical modeling, where you model how new drugs will interact with human body. There is a Pumas AI, a ready solution written in Julia exactly to do the simulation of how the drug will be working in human body, supporting the whole drug development life cycle. Or for example, in energy, I have two examples, like Invenia company uses Julia to manage the North American electrical grid, or for example, Tangent Works. This is a company from Central Europe. They have built an award-winning real-time energy forecasting and management solution, and really it was tested that it's producing excellent prediction quality models. But what is important, that because of speed of Julia, they are able to run it in real time. And for example, in financial sector, two very good examples are Aviva, where they use it for Solvency II calculation, and BlackRock, which is one of the leading companies that is managing customers' assets, where it's Julia powers parts of it Aladdin platform. So maybe just for Aviva, let me comment that by moving from other solution to Julia, Aviva was able to reduce both the number of computers that are used to run the platform from 100 to 5, and also the number of lines of codes was greatly reduced. So to sum up, our experience, both from academia, but also doing consulting job or working as a venture capital fund by Przemek, that we really see that currently Julia is already ready for production. Its core use are solutions that are very computing intensive, that require multiple threads or GPUs to solve the solution, and such problems are present both in research and in business. The important thing is that you can start using Julia without a problem, because it's really integrated really easy to integrate it into existing code bases, and this is what Przemysław has shown. So for example, I'm not know if you know volume package in Python, but actually this plot shows integration of Julia with volume, and it's just seamless. The developer does not even need to know that volume is used underneath for plotting those images. And finally, Julia has already a robust tooling. And the last thing, because we are in academia, and I think it's really important, Julia is really strong in academia currently, much stronger than in enterprise world. But this means that currently students get trained to use it, which means that, you know, in 2-3 years, they will be on a job market. So you will have people who know Julia to be able to safely deploy solutions using Julia, or also for enterprise customers. So I hope you found this introduction to Julia in production interesting, and if you have any questions, please ask them now. Thank you very much.